3, 2, 1, ignition.
Number 6. Falcon Heavy. Falcon Heavy is a powerhouse rocket built by SpaceX, designed to haul large cargo into space, whether that's into orbit around Earth or even beyond. It stands out because it's partially reusable, meaning parts of the rocket can come back to Earth and be used again, making space missions a bit more affordable. It's essentially a supercharged version of the Falcon 9, with 2 extra boosters strapped onto a central core, giving it much more lifting power. Falcon Heavy ranks right up there when it comes to carrying heavy stuff. It's got the second highest payload capacity of any active rocket, only behind NASA's Space Launch System (SLS). Historically, only a few missiles like the Saturn V and Energia have carried more. This makes Falcon Heavy a severe contender for launching big satellites or deep space missions. The rocket's first flight was in February 2018, and SpaceX made it quite the spectacle. Instead of a typical test payload, they sent Elon Musk's personal Tesla Roadster into space, with a mannequin named Starman in the driver's seat. It was a pretty wild sight, and it got everyone talking. The second launch in 2019 was another success, with all 3 boosters making their way back to Earth. Since then, Falcon Heavy has become certified for National Security Space Launch, or NSSL, missions, handling some of the most important and sensitive space projects. Interestingly, while Falcon Heavy was designed to carry people into space, SpaceX doesn't plan to use it for crewed missions. Instead, they're focusing on developing their next big rocket, Starship, which is expected to eventually take over both Falcon Heavy and Falcon 9. Number 5. RLV-TD. The Reusable Launch Vehicle Technology Demonstrator, or RLV-TD, is Indian Space Research Organization's big gamble in the world of space travel, aiming to make getting to space a whole lot cheaper. Picture it as a rocket that works a bit like an airplane. It's designed to go up, do its thing, and then come back down to be used again. The whole idea is to cut costs by reusing the same vehicle instead of building a new one for every launch. The RLV-TD is like a test pilot's dream. It's got a design that's part rocket, part airplane, with wings, a sleek nose, and even vertical tails. It's not just about looking cool, it's packed with technology to test out high-speed flight, autonomous landing, and powered cruising. The hope is that eventually this thing will be scaled up to become a key part of India's future space missions, serving as the first stage of a reusable rocket system that can carry heavier loads into orbit. The vehicle itself is a marvel of engineering. It's got a sturdy fuselage and some seriously advanced control surfaces to help manage its flight. For now, it's boosted to speeds of Mach 5 by a solid booster, which helps it get up to those high velocities without burning out too quickly. Building something like this isn't a walk in the park. It involves high-tech materials and a lot of skill. Special alloys and composites are used to make sure it can handle the extreme conditions of space, and it all comes together with some pretty sophisticated machinery. In short, ISRO's RLV-TD is a step towards making space travel more affordable and practical. It's still in the testing phase, but it's got the potential to change the game, making future space missions a whole lot less expensive and a lot more routine. Number 4. Falcon 9. Falcon 9 is a pretty groundbreaking rocket built by SpaceX, and it's been making waves since its first flight in 2010. It's a 2-stage rocket designed to be partially reusable, which means that, unlike most rockets that are used once and discarded, the Falcon 9 can land back on Earth and fly again. This innovation has completely shaken up the space industry by making space travel more cost-effective. One of the most impressive moments came in December 2015, when SpaceX landed the booster stage of the Falcon 9 after launch, marking the first successful recovery of a rocket's first stage. The way it works is simple. The rocket's first stage, also known as the booster, lifts the payload, whether it's a satellite, cargo, or astronauts, into a specific altitude and speed. Then the second stage takes over to propel the payload to its final orbit. Once the booster has done its job, it separates and heads back to Earth, where it lands vertically. This ability to reuse the first stage multiple times gives Falcon 9 a massive edge. In fact, as of September 2024, SpaceX has pulled off this landing 331 times, and some individual boosters have flown up to 23 times. The rocket runs on SpaceX's Merlin engines, which burn a combination of cryogenic liquid oxygen and a refined type of kerosene. It's a system workhorse, reliably powering both stages of the Falcon 9. The rocket's flexibility is also worth noting. It's been used to carry incredibly heavy payloads like the Telstar 19V satellite, which tipped the scales at over 7,000 kilograms. Falcon 9 has even set records, including one in 2021 when it launched 143 satellites in a single flight. One of the Falcon 9's most important achievements is that it's human-rated. This means it's been approved to carry astronauts, and in 2020 it became the first commercial rocket to launch a crew to the International Space Station. That's a big deal, because getting certified to carry humans is no small feat, especially for a private company. NASA has given Falcon 9 the green light for its most critical missions, and it's even listed as low risk for high-profile space flights. Over the years, Falcon 9 has evolved into different versions, with the latest, Block 5, flying since 2018. This version is designed for rapid reuse and is considered the pinnacle of the rocket's design. Overall, Falcon 9 has pushed boundaries and set the standards for how space missions are done, making space a little more accessible with every launch. Number 3. Rocket Lab's Electron. Rocket Lab's Electron is a small but mighty rocket designed to carry small satellites into orbit. It's built by Rocket Lab, an American company with roots in New Zealand. What's unique about Electron is that it's partly reusable, which is rare for a small lift rocket. This means parts of it can be recovered and reused, though Rocket Lab is still fine-tuning that process. Electron first took off in 2017, but that initial flight didn't quite make it into orbit due to a ground communication issue. By the second flight in early 2018, Electron reached orbit and successfully deployed satellites. Since then, it's been a reliable option in the small satellite market, racking up over 50 launches with only a few failures. It's currently the third most launched small lift rocket in history, which is impressive given its size and the competition. One of Electron's standout features is its engine. The Rutherford engine is the first to power an orbital-class rocket with electric pumps. It's a lightweight, highly efficient design, which uses lithium polymer batteries to drive the pumps. Nearly all its parts are 3D printed, making it faster and cheaper to produce. The rocket is made of carbon composite, keeping it light yet strong. It runs on RP-1 kerosene and liquid oxygen, just like many other rockets. Another exciting aspect is Electron's kick stage. This optional third stage helps put satellites into more precise orbits. It's powered by a Curie engine, and like the rest of the rocket, it's compact and efficient. Rocket Lab has also developed a version of this stage called Photon, which is meant for deeper space missions, including trips to the moon. Number 2. Vulcan Centaur. The Vulcan Centaur is United Launch Alliance's, or ULA's, newest heavy lift rocket, designed to handle big payloads for national security and commercial missions. It's set to replace ULA's older Atlas V and Delta IV rockets. The main goal of Vulcan Centaur is to launch satellites for U.S. defense and intelligence agencies, but it's also available for commercial clients who need to get heavy stuff into space. ULA started working on Vulcan in 2014, mainly because they needed a rocket to compete with SpaceX's Falcon 9. On top of that, Congress wanted to phase out the Russian RD-180 engines used in the Atlas V, so ULA needed to come up with something new. Vulcan was supposed to fly as early as 2019, but a series of setbacks, mostly related to the new BE-4 engines, and the Centaur upper stage kept pushing the launch date back. Finally, on January 8, 2024, Vulcan Centaur launched for the first time, carrying Astrobotic Technologies' Peregrine Lunar Lander, part of NASA's Commercial Lunar Payload Services, or CLPS program. Vulcan Centaur borrows some tech from ULA's Atlas V and Delta IV rockets, while bringing in new innovations to improve performance and lower costs. The Vulcan's first stage is powered by two BE-4 engines, which burn a mix of liquid oxygen and methane, liquefied natural gas. Methane is cleaner than the kerosene used in Atlas V engines, which means less pollution and better potential for reusability. It's also denser and has a broader temperature range than the liquid hydrogen used in Delta IV rockets, allowing for smaller, lighter fuel tanks. The rocket's second stage, called Centaur 5, is an upgraded version of what's been used on the Atlas III. It's powered by two RL-10 engines that burn liquid hydrogen and liquid oxygen. For extra power, the Vulcan's first stage can also be fitted with up to 6 solid rocket boosters. Despite being classified as a heavy lift rocket, the Vulcan Centaur is surprisingly compact, similar in size to medium lift rockets. It can carry a hefty 27,200 kilograms or 60,000 pounds into low Earth orbit when equipped with all 6 boosters, which is significantly more than Atlas V and almost as much as the massive Delta IV Heavy. Beyond heavy payloads, Vulcan is designed to meet the requirements of the National Security Space Launch Program. It's also being developed with the possibility of becoming human-rated, meaning it could eventually be used to carry astronauts aboard spacecraft like Boeing's Starliner or Sierra Nevada's Dream Chaser. Number 1. SpaceX's Starship. SpaceX's Starship is one of the most ambitious rockets ever built. It's not just big, it's a game changer in space exploration. Standing at 121.3 meters tall, this super heavy lift rocket is designed to handle missions once thought to be science fiction. It has 2 stages, the Super Heavy booster and the Starship spacecraft. Together, these 2 stages aim to lower the cost of launching spacecraft by making the entire system fully reusable. The Starship program has one main goal: to make space travel more affordable and frequent. SpaceX hopes to achieve this by reusing both stages of the rocket, which will ultimately help spread out the cost over multiple flights. The first stage, Super Heavy, is massive. It's powered by 33 Raptor engines that burn methane and liquid oxygen. This combination not only provides immense power, but also produces cleaner exhaust compared to other rocket fuels. Once the booster sends the Starship into orbit, it will return to Earth and be caught by mechanical arms attached to the launch tower. The second stage, Starship itself, is designed for versatility. It will be used to carry satellites, cargo, and eventually people. The spacecraft features 6 Raptor engines, 3 optimized for use in the vacuum of space, and it can carry between 100 and 150 tons of payload to low Earth orbit, or LEO. That's massive. Its payload bay is enormous too, big enough to carry missions to the Moon, Mars, and even further. SpaceX has also designed Starship with space refueling capability. This means one Starship can refuel another, allowing missions to distant planets like Mars to become a reality. They've even planned to use Starship as a part of NASA's Artemis Program to land astronauts on the Moon shortly. SpaceX plans to demonstrate this in 2025 with an orbital refueling test. With reusability, orbital refueling, and massive payload capacity, Starship could change how we think about space exploration. It's not just about going to space anymore, it's about going back and forth regularly. And with plans to use Starship for everything from satellite deployment to human spaceflight, SpaceX seems to have the future of space travel firmly in its sights. Hit that red subscribe button for more amazing informative videos, and see you in the next one.